In this video, we're going to talk about transformational graphing, which takes any function, any shape, and uses transformations to move the graph left or right, up or down, transform it by reflecting it, both x and y direction, as well as stretch and compress it vertically and horizontally. So this is another time where you really are going to want to pause and write down predominantly this part first before I continue. Okay, so what this is this shows you a function, and the parentheses, the outside parentheses, as you can see here in black, are going to tell you what shape the graph is. That can also be controlled by the grouping symbol with an exponent, for instance, a square or a cube. The grouping symbol can be a parentheses, but it could also be a variety of brackets, and that gives you the shape. Once you know the shape, this is going to be completed in the order of operations. So this right here being multiplication, and on the furthest left would actually occur first, and that is going to be a multiplier of output values or y values. Now keep in mind, multiplying by a number like 2 or 3, it will make the graph get taller, but multiplying by a decimal or a fraction smaller than 1 would actually make the graph shrink, which is called compression. Also, multiplying this by a negative will reflect the graph over the x-axis. The next thing you do from left to right is b. Now b is found by factoring out a common number between the inside of x and h, which is a constant. That number, because we are GCF factoring it, is actually going to divide the x values. It's inside, it's input, that's going to be x values. That again will compress or stretch the graph. Now think about this. If I divide a number by 2, that'll make it smaller. But if I divide a number by a half, that will reciprocate and multiply, making it larger. This will also reflect, and this will reflect over the y-axis. Now it may have sounded like I said that backwards, but reflections occur based on what is not changing. So if I multiply the y values by a negative, they will change. The x values will stay the same, so the reflection occurs over the x-axis. But if I divide the x values by a negative, the x values are changing, so the reflection occurs over the y-axis. Then we'll move into the left and right movement, which is inside the parentheses. Okay, so once we do that, that will add or subtract values to the input. That's going to effectively move it left or right. Now that being said, that negative right there means that we're going to define h as a negative value, meaning if it says 3 here, it's actually a negative 3 because negative makes a positive and things like that. So remember, negative means opposite. How about I say it like that? So whatever h appears to be, the graph moves in the opposite direction. The last thing is k, and in this case, the last thing is easy. Whatever k is, that's going to add or subtract to the y values, moving the graph up or down. So the vertex of any graph in vertex form, this is the vertex form of a function, as you can see in the title. The vertex of any function in this point is opposite of h once you have factored b out, and then comma k. All right, and I'm going to, everything I said, I've actually written down here, typed out for you. So again, I would advise you to pause and write this down in your notes. Very important part of your notes. This lasts for the rest of math, all the way through calculus. These items will always be the same for functions and translation. So go ahead and write that down. Okay, so as you can see, a little bit of differences in here is I did put the absolute value when I was talking about the value of a and b. And the reason that is because the negative actually does something else over here. So typically absolute values are put in here to tell you that all I really care about is the quantity, right? The magnitude value of a. So if you have a negative 3, that will stretch the graph vertically, but the negative goes over here in this box and reflects it over the x-axis. It does happen at the same time, as you can see when we'll do examples. Now if a is between 0 and 1, that simply means a fraction or decimal smaller than 1 but bigger than 0. If you multiply by something by 0, obviously nothing will result other than 0. This will compress the graph vertically. B is exactly the opposite, because remember, B is a divisor. So I have that right here, that this is a multiplier, this is a divisor. So if the absolute value of b is greater than 1, it's actually going to compress, make it smaller. Again, if b were 3 and I divided everything by 3, then the graph's going to get smaller. If b were a third, then that would reciprocate and then multiply by 3, making it bigger or stretching it. Okay, so remember, negative a reflects over the x-axis, negative b reflects over the y-axis, and again, I say reflections occur over the variable that stays the same. That's an important thing to remember. So then, remember, I'm changing the output here, so it's going to reflect over the x-axis. I'm changing the input here, so it's going to reflect over the y-axis. That's what that sentence means. So in this, the h, h is negative, so when h is negative, it translates to the left. When h is positive, it translates to the right. Makes perfect sense. Negative left, positive right. H is always the opposite value that it appears in the equation, as I mentioned up here, because it is negative. And down here, when negative k will move the graph down, makes perfect sense. When it's positive, it moves up, and k is exactly what you see. There's no change there.